Hello students, good morning. Welcome to online class standard 11 subject chemistry. Students, in the 11th standard chemistry, we have been discussing unit number 1, which is basic concepts of chemistry and chemical calculations. In that unit, we have discussed many topics so far, and today the most important topic which we are going to see is how to balance a redox equation. If you are given a redox chemical equation, how to balance the number of atoms in the reactant side and the number of atoms in the product side. Okay, so that is the concept of today's video class. What it is: balancing a redox chemical equation. Okay, dear students, there are two methods suggested for the balancing of the redox equation, and those two methods are oxidation number method and method number 2 is ion electron method. Okay, these are the two methods we are going to discuss, but today in this video we will discuss about the oxidation number method. Then in the coming video we will discuss the second one. Okay, oxidation number method. Look here students, you are given a chemical equation. Read it: FeSO4 ferrous sulfate reacting with potassium permanganate KMnO4, also with sulfuric acid H2SO4, and we get the products ferric sulfate. So in this reaction, the products we get are ferric sulfate Fe2SO4 thrice plus manganese sulfate MnSO4 plus potassium sulfate K2SO4, also a molecule of water which is H2O. So it is a chemical equation given FeSO4 plus KMnO4 plus H2SO4 gives Fe2SO4 thrice plus MnSO4 plus K2SO4 plus H2O. Okay, dear students, how to balance this reaction step by step? Let us see now. This oxidation number method consists of 5 different steps, and let us see them. Okay, step number 1. Step number 1 is identification of oxidized and reduced species. In the given equation, by applying the rules of oxidation number, initially we have to identify the species which gets oxidized and the species which gets reduced. That is the preliminary step have to be done while we balance a redox equation. So what is step number 1? Identification of oxidized and reduced species in the given redox equation. Okay, look here students, what is the first component? FeSO4 ferrous sulfate. If you calculate the charge of Fe in the case of FeSO4, its charge is found to be +2. Whereas for the same element, for the same ion, if we calculate charge in the product side, the answer is +3. So from this observation, what we can conclude is the ion has increased its charge from +2 to +3. And we know that whenever there is an increase in charge or increase in oxidation number is seen, we can say that that species has undergone oxidation. So it is given that Fe2 plus is oxidized to Fe3 plus. Okay, so we have identified the oxidized species. Then secondly, we have to identify the species which gets reduced. Look here, in the case of KMnO4, the charge of manganese is +7, whereas in the product side, the manganese is existing in the compound manganese sulfate, and here the charge of manganese is +2. So here what do we observe? The charge of manganese is decreased from +7 to +2. So it is called as reduction. We know that whenever charge is reduced, we can say that the species has undergone reduction. So dear students, step number 1 is completed. We have identified both the oxidized as well as the reduced species, isn't it? So here what is the oxidized species? Iron is the oxidized species. What is the reduced species? Manganese is the reduced species. Is it clear? Are you clear with step number 1? Yes. Then come to step number 2. Step number 2 is criss-cross multiplication. This I will explain you how to do this. Okay. So what is step number 2? Criss-cross multiplication. Look here students, take the given equation, find the charge difference, the difference in charges between the same compound in the reactant side and in the product side. Take iron, in the reactant side it is in +2 state, in the product side it is in +3 state. So what is the difference in charge between +2 and +3? It is 1. Can you able to understand? We have to find the difference in charge between the same compound in the reactant as well as in the product side. So here what is the charge difference? 1, and that is mentioned as 1 electron. Okay, it has to be multiplied with the number of atoms. How many iron we have in the reactant side? We have 1, whereas in the product side we have 2. So this 1 electron have to be multiplied with 2. So 1 electron into 2. Then secondly, the reduced species, manganese. Here what is the charge? +7 is the charge. In the product side, +2 is the charge. So what is the difference between +2 and +7? It is 5. And so it is written that 5 electrons into 2. Okay, 5 into 2, 10. Now this 10 you have to multiply it with the first component, whereas this 2 you have to multiply with the second component. This is called as criss-cross multiplication. After doing this multiplication, the answer is 10 FeSO4 plus 2 KMnO4 plus H2SO4. Okay, so this is called as criss-cross multiplication, step number 2. Okay, with this step number 2 is over. Then let us see the step number 3. Step number 3 is, from step number 3, balancing starts. We have to balance the atoms step by step. Okay, in step number 3 what you have to do is, we have to balance the oxidized and reduced species. We know that in this given equation, the oxidized species is iron and the reduced species is manganese. This we know. So first these two atoms we have to balance. Okay, look here, the given equation is 10 FeSO4 plus 2 KMnO4 plus H2SO4 gives Fe2SO4 thrice plus MnSO4 plus K2SO4 plus H2O. Okay, count the number of atoms, number of iron atoms in the reactant side. We have 10 iron atoms in the reactant side, but in the product side we have only 2 iron atoms. Then how to balance this? How to convert this 2 into 10? When this is multiplied by 5, it will be equal. So in front of this Fe2SO4 you have to write 5. Now 5 into 2, 10. So in the reactant side also 10 iron atoms, and in the product side also we will have 10 iron atoms. Okay, so the oxidized species is balanced. Then we have to balance the reduced species, which is the reduced one, manganese. In the reactant side, how many manganese atoms we have? We have 2 manganese atoms. Okay, but in the product side we have only 1 manganese atom. So what we have to do? We have to write 2 in front of this MnSO4. Okay, and after doing these 2 changes, this equation becomes, in the product side I am reading 5 Fe2SO4 thrice plus 2 MnSO4 plus K2SO4 plus H2O. Okay, Mama. So in the step 3 what we have done? We have balanced the oxidized and reduced species alone. Okay, okay. Then come to step number 4. In the step number 4, what we will do is balance the atoms other than hydrogen and oxygen. Okay, except hydrogen and oxygen we have to balance the remaining atoms. That is step number 4. Okay, okay, look here. The equation I have taken, the equation which I have got from step number 3 I have taken, that is 10 FeSO4 plus 2 KMnO4 plus H2SO4 gives 5 Fe2SO4 thrice plus 2 MnSO4 plus K2SO4 plus H2O. Okay, okay. Already iron we have balanced. Okay, then come to sulfur. How many sulfurs we have in the reactant side? Let us calculate. See here, 10 sulfur. Then here in the sulfuric acid, 1 sulfur. So totally how many sulfurs we have? We have 11 sulfurs in the reactant side. Then come to the product side. In the product side, how many sulfurs we have? Look here, 5 into 3, 15. 5 into 3, 15 sulfur. Here 2 sulfurs, 15 plus 2, 17. Here 1 sulfur, 17 plus 1, 18. So in the case of sulfur atom, reactant side we have 11, whereas in the product side we have 18. So in the reactant side we have to increase the number of sulfur atoms. Let it be. Then let us balance the next atom. Potassium. Look at the potassium. How many potassiums we have in the reactant side? 2 potassiums. In the product side, how many potassiums we have? 2 potassium. So potassium is balanced. Manganese is already balanced. Okay, well? Okay. Now what we have to do? We have to increase the number of sulfurs. Here 11 sulfurs we have. Here we have 18 sulfurs. So in the reactant side, we have to increase the number of sulfur atoms. How to increase? Look here. If you write here 8. Now count the number of sulfur atoms. 10 sulfur plus 8 sulfur. Totally we have 18 sulfur. Okay. Now sulfur is balanced. Potassium is balanced. Okay. Well? Okay. Now this equation is written like this. Look here. 10 FeSO4 plus 2 KMnO4 plus 8 H2SO4, which gives 5 Fe2SO4 thrice plus 2 MnSO4 plus K2SO4 plus H2O. So with this, step number 4 is over. In the step number 4, what we have done? We have balanced the atoms except hydrogen and oxygen. Okay, okay, then let us see the step number 5. Step number 5 is we have to balance hydrogen and oxygen. Okay, okay. So take the equation obtained from the step number 4. What is the equation we have got from step number 4? This is the equation we have got from the step number 4. Okay, count the number of oxygens. How many oxygens we have in the reactant side? 4 into 10, 40. Then here 4 into 2, 8, 48. Here 4 into, sorry, let us balance the hydrogen first, then let us balance the oxygen. Count the number of hydrogens. How many hydrogens we have? 8 into 2, 16. In the reactant side we have how many hydrogens? 16 hydrogens. In the product side we have only 2 hydrogens. Okay, so how to convert this 2 into 16 in front of this H2O? If you write 8, 8 into 2, 16. Okay, so number of hydrogen atoms balanced. And surprisingly, dear students, when we write 8 in front of H2O, automatically the oxygen is balanced. You can calculate and see how many number of oxygens in the reactant side and how many number of oxygen atoms in the product side. Okay, and finally the balanced equation is given here. 10 FeSO4 plus 2 KMnO4 plus 8 H2SO4 gives 5 Fe2SO4 thrice plus 2 MnSO4 plus K2SO4 plus 8 H2O. In certain cases we have to balance the oxygen atoms also. But in this equation, surprisingly, when we balance hydrogen, automatically the number of oxygens balanced. Okay, so with this, balancing of a redox equation is over. Okay, dear students, are you clear how many steps it contains? It contains 5 different steps. What is step number 1? Identification of oxidized and reduced species. In the given equation, you have to identify which species is oxidized and which species is reduced. And in the step number 2, we have to follow a method called crisscross method. Step number 3 is you have to balance the oxidized and reduced species alone. And step number 4 is you have to balance the atoms other than hydrogen and oxygen, and finally balance hydrogen and oxygen to produce the balanced redox chemical equation. Okay, dear students, with this video ends. It's the most important topic, as I told you in the beginning of this video. You can watch the video twice to have a clear understanding. Thank you.